Okay, so question 4 is a stats question again, and the first thing it wants to do is construct a back-to-back stem and leaf plot of the above data. So doing out stem and leaf plots takes a bit of time. You'll see in after I finish this, I'm going to fast forward me putting everything in. I'm just going to go through how to put in the basics, and then the video will fast forward me just filling out the whole thing. Alright, so the first thing I'll do is I'll look at my data, and over here I see that my lowest number is 14. Alright, so 14 is the lowest number, and over here the lowest number is 9. And then I look for the highest number, which is 86. Alright, so there it is there. And the highest number here is 88. Alright, so now I know that I have to go from 0, 10, 20, 30, 40, 50, 60, 70, 80. There is no need for me to go any further because there is no results in the 90s. So the stem represents tens. So that's from 0 to 9. This is 10 to 19. This is 20 to 29. Okay? And so we fill it in. So if I want to fill in the 9% for class 2, I'm going to put a 9 here. Alright, that represents that guy. And then I have a 12% and a 15%. So 12 and 15. Okay? So for class 2 then, I'm just going to go through the rest then. So 2, 4, 2, and then for class 1, 14 being my lowest. Alright, so 14. Then there's nothing in the 20s or the 30s. And 4 has a 2, 4, 4, and 8. There's a 1 here, a 6, and an 8 here. A 0, a 0, a 1, a 7, and an 8. A 1 and a 6. Okay, so just in case you're confused as to what these numbers represent, this represents a student who got 9%. This represents a student in this class who got 12%, who got 15%, 22%, 24%. While in class 1, this guy got 14, this guy got 42, 44, 44, 48. Okay, don't forget your key. Alright, as you can see, this student should have gotten 10 but lost 1 because he didn't have a key. So just represent, so let's take the example of 6. So this and a 0 beside it means 60%. Okay? How many students were in each class? Now guys, you can't be gifted an easier question than this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. So 18 in class 2. Alright? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 in class 1. Alright? So then it says the research data about the student scores collected here is an example of what type of data. Circle your answer below. Well, the data is in numbers, so straight away it's definitely not categorical. Alright, so you can eliminate those two guys straight away. So we're looking at numerical discrete or numerical continuous. Now, I take a small bit of an issue with this question because technically grades can be continuous, but not really, okay? So numerical continuous doesn't count. What am I talking about here? Continuous means that potentially a student could score 9%, they could score 9.1, 9.2, 9.3, 9.4, 9.44444. Do you get me? There's no kind of limit to what the student can get. But in reality, in an exam, when you're given percentages, you know, it's either 9%, it might be 9.5%. It's got discrete, it's a set amount. Okay, so it's numerical discrete is the answer there. Okay. Then it says find the interquartile range for students from class 1. So I'm going to have to actually go back to this guy here for a minute. Okay, so we'll start with class 1. If I want to find the interquartile range, well, I got to count up how many I have. I have 15 altogether. All right. Quartile means divide by 4. If you divide 15 by 4, you will get 3.75. Now you always round this up to the next. Even if that was 3.01, round it up to 4. Okay? So 4 is what we want to get for our quartile. So our quartile is 4, so I go 1, 2, 3, 4, and I'm left with 71 there. So my Q3 is equal to 71. That's my third quartile. My first quartile will be 1, 2, 3, 4. Actually, sorry guys, I made a little mistake here. That guy, 70. 70 is my third quartile, and 44 is my first quartile. Okay? For class 2, alright, This time it's 18 divided by 4, which gives me 18 divided by 4, which is 4.5, which I'm going to round up to 5. So we'll start with the third quartile like I did over there. So third quartile is going to be 1, 2, 3, 4, 5. It's 50. All right. And the first quartile is going to be 1, 2, 3, 4, 5. It's 24. Okay. So I'm just going to write that out into this here. So class 1. All right. Q3 is equal to 70. Q1 is equal to 44. So the interquartile range is 70 minus 44, which gives me 26. All right, that's class 1. For class 2, the third quartile is, what did we say it was? It was 50. All right, and the first quartile is 24. All right, and interquartile range is going to be 50 minus 24, which is also 26. So they have the same interquartile range. Oh, I didn't realize there was a spot there, so all that should be written into that there, but sure, it's all good in the hood. Explain the meaning of the term outlier and give one example from the data above. Okay, so class 2 provides us with a good example of an outlier. So I'll come back to this guy here, all right? And if you look at this, all the data is relatively squished up here, and then there's it jumps from 60 to 88. So clearly, it doesn't take much of a stretch of the imagination to realize the student who's getting 88 is a good bit better, or is scoring a good bit higher than the rest of the students here, right? So he's unusual compared to the rest of them. So he's an outlier. That's what we mean. So a way I describe it is an outlier. I'm going to write this all out now. An outlier is a piece of data, okay, that is an extreme value compared to all other data points or all other pieces of data. All right, so that 88 is significantly higher than the rest of the data that was available. So I will say class 2 had a result of 88%, which is, and this is a good word to use, significantly higher than the rest of the class. All right, so it's significantly higher than the rest of the class. All right, so that's the definition of an outlier. Which class do you believe achieved better results in this test? Justify your answer statistically. There's a couple of ways you could have done this. You could have done the hard maths, added up all of class 1 divided by 15, added up all of class 2 divided by 18, gotten the mean, and then said, well, this class got a higher mean than the other. But there's actually a simpler way, all right? If you look at the data that they've given us, okay, I'm just going to use a different color pen for this, right? So if I was to actually just draw a little line around the numbers, okay? Okay, just like that. Doesn't have to be exact. All right. You can clearly see that there's a big lump in the middle for class 2, and there's a big lump kind of down here for class 1. So the way you can see it. Most of the students have done quite well. They've all but one have passed. All right, and a good amount of them got into the 70s and even the 80s. While over here, a good amount of students passed, but they've a good bit down in the fail rate as well. Okay, so you know you could write that out in your own words, but let's try and actually use the statistical words that we should be using for this, right? So class 1 or class 1's data is skewed. All right. Now, if you hold this upside down, it looks like it's skewed to the left, but actually you describe that as being skewed right. Imagine an arrow going down to the right here, so it's skewed right. Okay. So class 1's data is skewed right, while class 2's data is skewed left. All right. Hence, class 1 has performed better. All right. Okay. Oh, I went off the page there. All right. So there you have it. That's question 4.